A proportion is an equation that states two rates or ratios are equal. For example, if we have 250 miles over 5 gallons, this is a rate. This is the same rate as saying 50 miles over 1 gallon. They simplify to both the same thing, so we know that those two things are equal to each other, and we can write that as a proportion. One of the important things about proportions is that the units that are in the numerator, in this case miles, have to be the same on both sides of the proportion, as well as the units for the denominator. In this case we have gallons. Those have to be the same on both sides. This is different from our measurement conversions that we did in 3.2, and that's because we are setting these equal to each other. I am saying that this rate here of miles over gallons is equal to the other rate, so my units have to be consistent. They have to be miles per gallon. Our conversions, we're multiplying to cancel things out, so with those they have to be flipped, but with proportions they have to be the same on both sides. The other tricky part with this is a proportion can have ratios instead of rates. And with ratios, we don't include the units with them. Our ratios are unitless. So this can make it a little bit tricky in the setup of word problems when we're given problems that deal with ratios and not rates. But you just need to be very careful with the setup to make sure that both sides are representing the same thing. So now we're going to go over the quick definition here of a proportion. So if we have A over B and C over D, and these are equal ratios or rates, then we can set them equal to each other. A over B equal to C over D, and this is what we call a proportion. So when they're set equal to each other, that is the proportion. And the nice thing about proportions, if one of the terms is unknown, so one of these 4 letters in this, we don't know what it is, it's the variable still, but the other 3 spots in the proportion are filled in with numbers. They have their values. We can then figure out what that unknown is. We can solve for it. So we're going to work through this example here where we have the proportion 3 over 8 equal to n over 12. And I'm going to work through 2 different methods on how to solve this. This first method here, I think is most useful when the variable that we're trying to solve for, in this case n, is in the numerator of a fraction. With this, what I do is I see that n is being divided by 12, so in order to undo that, I can just multiply both sides of my equation by 12. Because that will then cancel out the dividing by 12 on the right side. And now I know that I'm going to have 12 times 3, which is 36, divided by 8, and this is equal to n. So now we can evaluate this and say that n is equal to 4.5. The next method here for solving a proportion is what we call as being the cross product method. And with this, I think it's usually easier to use when the variable is in the denominator, but we can also use it on any proportion that we have. So I can use it to solve this one, same problem as well. And how we solve with the cross product method is we take the diagonals of each other. and multiply those together. So I am going to have 8 times n, and then I want to take the other diagonal, which is going to be 3 times 12. And then the cross product method here tells us that both of these two things are equal to each other. So we have 8 times n equal to 3 times 12. I want to solve for my n here. So n is being multiplied by 8. We need to divide both sides of our equation then by 8 to undo that. So we have n equal to 3 times 12, which is 36, divided by 8, which is our 4.5 that we stated earlier.